everyone. Welcome to Swam's online lecture series on the topic database management system. I am Mohammad Bukhari, working as a professor in the Department of Computer Science, Aligarh Muslim University. I am pleased to have you join me today again to learn few more important topics from the database management system worlds. Today, in the next few minutes, we will learn the topic including data modeling using relational domain characteristics, and tuple relational calculus. I wish you I wish you will enjoy and find this lecture fruitful your academics. In the previous session, we have discussed relational algebra and fundamental operators. Before proceeding with today's agenda, I would like to discuss question that I had given you in the last class. The first question was explain the purpose and significance of relational algebra in database management system. The answer is relational algebra serve as a theoretical foundation for relational databases, providing a formal framework for query formulation and optimization. Its purposes lies in facilitating operations like selection, projection, join, and union, which manipulates relation to retrieve desired data. Significantly, it enables user to express queries in a structured manner, aiding in database design, query optimization, and implementation of database systems. Relational algebra form the basis for query language like structured query language, allowing user to interact with the database effectively. Its significance lies in providing a semantic approach to database querying, ensuring data retrieval efficiency, and maintaining data integrity in database management system. The next question was, how does relational algebra contribute to query optimization and performance improvement in database system? Relational algebra aids querying optimization by providing a formal framework to express queries. Data system leverage this to analyze and optimize query execution plans, selecting the most efficient strategies. Operations like selection, projection, and join are optimized using techniques such as indexing, join algorithms, and query rewriting. By understanding the algebraic operative, by understanding the by understanding the algebraic properties, the system can reorder operations and minimize costly disk access, leading to improved performance. Additionally, relational algebra serve as the basis for query optimization algorithm and cost estimation model, enabling database system to deliver faster query processing and enhance overall performance. The, the third question was discuss the role of selection and projection operations in query formulation and data retrieval in relational algebra. The answer is selection and projection operators plays crucial role in query formulation and data retrieval in relational algebra. The selection operators filters tuples based on a specified condition, allowing user to retrieve only the relevant data that meets certain criteria. This enables precise data extraction, enhancing query accuracy and efficiency. On the other hand, the projection operator select specific attributes from relations, enabling user to focus on the relevant information and reduce data redundancy. Together, these operators facilitate targeted data retrieval, optimizing query performance, and improving the overall efficiency of relational database system. The last question was explain application of relational algebra in the detail. Relational algebra finds diverse application in database management system. It is pivotal. It's pivotal for query processing, enabling users to retrieve, manipulate, and manage data for efficiently. Specifically, specifically, relational algebra forms the backbone of structured query language, the standard language for relational algebra database. It facilitates complex query formulation, data manipulation, and schema design. Additionally, relational algebra powers query optimization techniques, enhancing query performance by selecting optimal execution plans. It is instrumental in implementing database operations like join, selection, projection, and union. Moreover, relational algebra underpin database design principles, ensuring data integrity, normalization, and efficient storage structures, making it indispensable in various aspects of database development and management. So, I have told you earlier the agenda of the today's lecture is to discuss relational domain, relational domain characteristics, and tuple relational calculus. So let us start today's lecture and understand what is relational domain. If we talk about the data types defined for a column in database is called a database domain. This type can either be a built-in type such as integer or a string or custom type that defines data constraints. Domain constraints are user-defined columns that assist the user in entering values that are appropriate for the data types. If it, detect, if it detects an incorrect input, it informs the user that the column is not properly filled, or to put it another way, it is an attributes that describe all the potential values for the attributes such as integer, character, date, time, string. In database management system, a relational domain represents a set of allowable values for a particular attributes within a relation. It defines the data types and constraints that govern the values that can be stored in the attributes. For instance, consider an attribute's age in a table representing implies the relational domain for age might specify that it can only contain integer value ranging from 18 to 100. This, con- this constraint this constraint ensure that only valid age values are stored in the database, maintaining data integrity. Relational domain can include various data types such as integer, floating point number, string, dates, and more. They may also enforce additional constraints like uniqueness, nullability, and referential integrity. By defining relational domain, database designer establish rules for data stored in the database, ensuring consistency, accuracy, and reliability. Furthermore, data, furthermore, database management system uses information about relational domain for query optimization, indexing, and enforcing data integrity constraints, thus playing a crucial role in the overall functionality and performance of the database system. Now let us see the types of domain constraint. So there are the following types of domain constraint. Not null. The not null constraint usually prevent a column from accepting null values. That means the void or blank values. This implies that you cannot create a new record or change an existing one without first putting a value in the field. Check constraints. This constraint basically restricts the value of a column across the ranges. It can also be it understood it can also be understood as it is like a conditions or filter checking before saving the data into column since it defines a condition that each row must satisfy. Now we are able to understand relational domain characteristics. In database management system, relational domain characteristics encapsulate the properties and constraints that govern data values within a specific domain. These characteristics ensure the integrity, consistency, and reliability of data stored in relational databases. Domains may also specify data range limit, nullability, default values, collection value rules, and character sets, providing flexibility in data representation while maintaining the constraint on the required data values. Moreover, characteristics like data size, precision, scale, format, and collection rules ensure efficient storage utilization, accuracy in calculations, and consistency in data presentation. Overall, relational domain characteristics define the structure and behavior of data within the database management system, ensuring consistent, reliable, and usable data throughout the database system. There are the relational domain characteristics you can see on the screen. Relational domain data types. Next is relational domain design, relational domain validation, relational domain evolution, relational domain specific languages, relational domain aggregates, relational domain partitioning, relational domain specific indexing, relational domain refactoring, relational domain specific security, relational domain data types. In database management system, a relational domain data types may be refers to a specific types of data that can be stored in attributes within a relation. It defines the format and ranges of values that the attributes can hold. Relational database system support various data types to accommodate different kinds of information. Common relational domains data types includes integer, float or double, character string, date, time, boolean, decimal number, you can say decimal or numeric, binary, and the last is timestamp. Timestamp represents a combination of date and time information. Relational domain data types are very essential for ensuring data integrity and consistency within a database. They determine how data is stored, retrieved, and manipulated, and they help enforce constraints and rules on the values that can be inserted into attributes. Additionally, database management system provides support for converting data between different data types and performing operations and calculations based on the data types of attributes. Overall, understanding and appropriately selecting relational domain data types are crucial aspects of database design and management in database management system. Relational domain design. Relational domain design in database management system refers to the process of defining and structuring the domains or set of allowable values for attributes within the relational database schema. It involves determining the data types, constraints, and other characteristics of each attribute to ensure data integrity, consistency, and usability. The key aspect of relational domain design includes data types, domain constraints, nullability, default values, data size and precision, collation and character sets, and format. Relational domain validation. Relational domain validation in database management system may be refers to the process of ensuring that data values inserted into attributes within a relational domain meet specified criteria or constraints. This validation is essential for maintaining data integrity, accuracy, and consistency within the database. Relational domain validation typically involves several types. Relational domain validation typically involves several steps. Now let's understand what them one by one. Defining constraint. Establishing constraints such as data types, length, format, and range for each attribute within the domain. For example, a domain constraint may specify that date of birth attributes must be a type of date and should not allow future date. Data type validation. Verifying that the data types of inserted value matches the expected data types for the attributes. For instance, ensuring that numeric attributes only accept numerical values and reject non-numerical inputs. Length validation. Checking the length of a string values against the specific maximum length for a string attributes. This ensures that data does not exceed a storage limit and prevent data truncation. Format validation. Validating that data values adhere to a specified format such as date or time format. For instance, ensuring that the date value is entered in the format year, month, and day. Range validation. Ensure that numeric value fall within the specified range or boundaries. For example, validating that an age value is within the reasonable range such as 0 to 150 years. Constraint enforcement. Enforcing constraints such as primary key, foreign key, unique, and check constraints to maintain the data integrity. These constraints prevent the duplicate entries, maintain referential integrity, and enforce specific conditions on attributes value. Handling null values. Determining how null values are handled based on the nullability constraints specified for each attribute. This may involve rejecting null values for attributes that require not null values or allowing null values for optional attributes. Relational domain validation helps ensure that only valid, accurate, consistent data is stored in the database, reducing the risk of data corruption, errors, and inconsistencies. It plays a crucial role in maintaining the data quality and reliability, thereby enhancing the overall usability and effectiveness of the database system. Relational domain evolution. Relational domain evolution in database management system refers to the process of modifying and updating the characteristics of relational domains over the time to accommodate changes in the data requirement, business rules, or technological advancement. This evolution is essential for ensuring that database schema remain adaptable, scalable, and aligned with the evolving needs of the organization. Relational domain evolution typically involves the following steps: identifying changes, next analyzing impact, planning modification, testing changes, data migration, the last is documentation and communication. Relational domain aggregates. Relational domain aggregates in database management system are functions used to perform calculations or operations on the group of data within a specific relational domain. These aggregates help summarize the information across row and column, providing values, insight into trends, patterns, and summary statistics within the database. The most common relational domain aggregates include count, sum, average, mean, max. Now understand with the help of example, consider a sale database where each record represents a sale transactions including the product sold and corresponding revenue. By applying the sum aggregates function with group by on the product category, user can obtain the total revenue for each product category, providing valuable insights into the sale performance across the different product segment. The next is relational domain partitioning. Now as you can see on the screen, relational domain partitioning in the database management system involves the dividing data within the specified relational domain into a smaller, more manageable subsets. This process can occur horizontally or vertically. Now you Now, as you can see on the screen, relational domain partitioning in the database management system involves the dividing data within a specific relational domains into a smaller, more manageable subsets. The process can occur horizontally or vertically. Horizontal partitioning, also known as sharding, this method involves dividing rows of data across multiple storage locations based on predetermined criteria. Vertical partitioning. In this process, columns within a table are divided into separate storage structure. This partitioning is typically based on the usage pattern or access frequencies. For instance, frequently accessed column may be stored separately from less frequently accessed one, allowing for more efficient data retrieval. Additionally, column containing large or infrequent use data such as BLOBs, binary large objects, or CLOB, character large objects, may be stored in separate partition to optimize storage utilization. Relational domain partitioning offers several benefits in database management system. First is scalability, next is performance, next is manageability, fault tolerance. Relational domain specific language. Relational domain specific language in database management system are a specialized language designed to facilitate the definition, manipulation, and querying of data within a specific relational domain. Unlike general purpose programming languages like structure queue language, which operate at higher level of abstraction, DSL are tailored to the unique characteristics and requirement for particular data domain. These languages typically offer syntax, semantic construct optimized for working with specific types of data, making them more intuitive and effective for domain specific tasks. Here are some key aspects of relational domain specific language. First is focus, scope, expre- expressiveness, abstraction, next integration, optimization, extensibility, tooling and support, PL, PGSQL, GUI, SparkQL, TSQL, PLSQL. These are the PLSQL, Oracle's procedure extension to SQL, used to developing a store procedure function and triggered in the Oracle database. Relational domain specific languages enable user to work more effectively with the specialized data domains, allowing for greater productivity, flexibility, and performance when working with the domain specific data within the relational database environment. Relational domain specific indexing. Relational domain specific indexing in database management system involves the creation or definition of indexes tailored to specific data domains within a relational database. Unlike traditional indexing methods that apply to entire database or column, domain specific indexes enforces domain specific indexes. Domain specific indexing focuses on optimizing performance for queries and operations within the specific domain or subset of data. Key aspect of relational domain specific indexing includes selective indexing, custom index structures, indexing based on access pattern, multidimensional indexing, composite indexing, index maintenance. Relational domain specific indexing aims to optimize query performance and data retrieval efficiency for a specific subset of data within a relational database by tailoring indexing strategies to the characteristics and requirement of individual data domain. Database management system can achieve improved performance and scalability for domain specific queries and operations. Relational domain refactoring. Relational domain refactoring in database management system involves restructuring and optimizing the design of relational domains within the database to improve performance, maintainability, and scalability. It aims to enhance the operation. It aims to enhance the organization, clarity, and efficiency of data representation within specific domains while minimizing disruption to existing application and process. We will also learn all the aspects of it in detail. The key aspect of relational domain refactoring includes normalization, already know, denormalization, partitioning, indexing, index optimization, data type optimization, constraint management, partitioning. Relational domain refactoring is an iterative process that requires careful planning, analysis, and execution to ensure domain database management system can adapt to evolving business needs, improving performance, and enhance overall database usability and maintainability. Relational domain specific security. Relational domain specific security in database management system involves implementing security measures at the level of specific data domains within a relational database. This approach allows for more This approach allows for more granular control over access to sensitive or critical data, ensuring that only authorized access or entities can be interact with or within those domains. Only authorized users or entities can interact with data within those domains. Now let us see the importance key aspect. The key aspect of relational domain in specific security includes access control, data encryption, auditing and monitoring, data masking, fine-grained control, role-based access control. Overall, relational domain specific security aims to protect sensitive data within specific domains from unauthorized access, modification, and disclosure, while still allowing authorized user to access and interact with the data they need to perform their task. By implementing targeted security measures at the domain level, organization can strengthen their overall data security posture and mitigate the risk of data breaches and unauthorized access. Tuple relation calculus. Tuple relation calculus is a non-procedural query language used in relational database management system to retrieve data from tuples. Tuple relational calculus is based on the concept of tuple, which are ordered set of attributes, values that represent a single row or record in database table. Tuple relational calculus is a language, or we can say a formal language used in database management system for specifying queries to retrieve data from relational database. It provides a declarative approach to expressing data queries, focusing on what data is desired rather than how to retrieve it. Here is, let us see the more explanation of TRC. Variables, formulation, quantifier, logical conditions, results. TRC provides a powerful and expressive language for querying relational database, allowing user to specify complex retrieval criteria in a concise and intuitive manner. It offers a high level of abstraction, enabling user to focus on the desired data without being concerned with the detail of how data is retrieved. Tuple relational calculus requires can be translated into executable code by DBMS query processor, which generates an execution plan to retrieve the requested data efficiently from the database. TRC is declarative language, meaning that it specifies what data is required from the database rather than how to retrieve it. TRC requires are expressed as a logical formula that describes the desired tuples. In parentheses, T belongs to PT, where T is the tuple, where T is a tuple variable, and PT is a logical formula that describes the condition that the tuples in the results must satisfy. The curly brackets are used to indicate that the expression is a set of tuples. For example, as you can see on the screen, let us consider a relation R with attributes column A, B, and C. If for every combination of values A, there is only one corresponding values B, we say that B is functionally dependent on A determines B. Similarly, if A determines both B and C, we can express this A arrow B and A arrow C. In today's lecture, we discuss about the relational domain characteristics, and tuple relational calculus. Now let us access your knowledge and track your progress with some important questions. Your answer will enhance your concepts as well as make you more aware about the topic. The today's question to test your knowledge are: what is relational domain and how does it relate to the concept of attributes in relational database? The next is: what are the key characteristics of relational domain and why are they important in database design? What are the advantages of using domain constraint to enforce the data inconsistency? What are the advantages of using domain constraint to enforce data consistency in database? The last question: what do you mean by tuple relation calculus, and explain it in detail. In our exploration today, we have navigated the intricate world of data modeling using relational domain characteristics, and tuple relational calculus. In today's lecture, we have discussed important topics of relational domain and tuple domain. In today's lecture, we have discussed important topics of relational domain and tuple relation calculus, which will help you in your academic as well as information industry. I hope you enjoyed this lecture. Hope to see you soon in the next lecture. Till then, keep revising and stay connected. Thank you.